Doppler radars measure the phase shift between an emitted pulse and the energy scattered back to the radar to estimate velocity. A target's velocity is comprised of the speed and direction of the target. Negative velocities, which are illustrated as greens, blues, and pinks on typical radar programs, represent targets that are moving toward the radar. These are also called inbound velocities. On the other hand, positive velocities, your reds, oranges, and browns, represent targets that are moving away from the radar. These are outbound velocities. Velocities near zero show up as gray. Depending on the radar program you're using, velocity is measured in either knots or miles per hour. Typically, higher velocity values indicate targets moving more quickly, but this depends on the radar's maximum unambiguous velocity.
Storm chasing is hard. Get expert help from a live coach. Discord community link in description.
The velocity of a target that you see on a radar program will almost always be slightly less than the actual velocity of the target because radars are at fixed locations, meaning that they can only measure how fast a target is moving toward or away from the radar itself. This is called radial velocity. Every azimuth angle, which is the radar beam's angle from due north, is associated with a radial. Radial velocity is equal to the actual velocity of the target only when the target's motion is directly toward or away from the radar. In other words, directly along a radial. Therefore, the greater the angle between the radar beam and the target's motion, the less the portion of the target's actual velocity that will be sampled, and the less the radial velocity will be. If a target is moving perfectly perpendicular to the radar beam, its radial velocity will be zero. In addition, standard radial velocity, which I'll refer to as just velocity or base velocity from here on out, is the target's velocity relative to the ground. However, storms and their small-scale phenomena, like tornadoes, move with respect to the ground, which can make it difficult to obtain proper velocity measurements. For example, if a storm has 40-mile-per-hour winds and is moving directly at the radar at 30 miles per hour, the radar will output an erroneous base velocity of 70 miles per hour. To combat this, we can use a product called storm relative velocity, which subtracts out the storm motion. This can make it much easier to discern areas of rotation within the broader wind field.
Remember to check out those links in the description below, and then watch another video.